Okay, so we're going to look at 2.1, a bunch of properties of exponents. So our goal today will be for students to be able to simplify the exponential expressions involving powers, and also be able to do the algebraic ones. What happens if there's x's, y's, and z's? And we'll find out. So we're going to learn about various properties, and I'll show you several examples involving the properties, and you will then be doing your study guide. We'll probably do much of the study guide as we go, and so Let me plug in my Mobi. Okay, so first property of exponents. If you're multiplying two exponential numbers, you need to add their exponents if you have the same base. So here's an example. Oh, hang on. Thought I had examples there. Okay, so.
Stop the lesson.
Huh?
Stop the lesson.
Stop the lesson. Like, let me just make up an example. Yeah, that's fine. What if we have like 3 to the 4th power times 3 to the 7th power? Well,
It's 3 to the 11th power.
3 to the 11th power, right? All you do is you add the exponent. Now, just one time I'll show you what this looks like in an expanded form. 3 times 3 times 3 times 3. See, there's that one, right? Shh. All right, and then this one, 3 to the 7th, you'd have 3 times 3 times 3 times 3 times 3 times 3 times 3. And if you notice here, there's altogether 11 threes. And so we could rewrite it like that. Easy so far, right? So let's move on to the second one. So this is an exponent raised to an exponent. And to do this, you'll notice there's a set of parentheses involved, so that way we don't get confused with the 2-digit number up here. So, for example, we might have 5. You see, if you didn't write the parentheses, you might write 25 like that, to 25th power. To clarify the confusion, we'll put the parentheses in here like that. And now we will know that it's 5 squared to the 5th power. And to simplify this one, all you do is multiply the exponents. So you get 5 to the 10th. Now again, if you want to write it out in expanded form, you can see how it works. This would be 5 squared times 5 squared times 5 squared times 5 squared times 5 squared. And of course this would be 5 times 5. This one would be 5 times 5. And this one would be 5 times 5. And this one would be 5 times 5. And this final one would be 5 times 5. And as you can see, how many times are the 5s there? There's 10 of them. So it's probably easier just to use the property of exponents, which say you can multiply the exponents. Easy so far, right? We only got about 6 more properties to go. And some of these will be tricky. All right. So let's move on to the third property. Now this one may look similar to this one, doesn't it? It does kind of. It has parentheses involved. And this one basically looks like a distributive property. Like you put the exponent here and you put the exponent there. And that's kind of what happens. You gotta be careful though. Make sure you understand the difference between this one. Now this is the distributive property I was just now talking about. When we have a number out in front, we multiply it by everything on the inside here. We get 2 times x, we get 2x, and then 2 times 6, we get 12, right? And you guys still remember the FOIL method and all that junk. Well, make sure you don't get this idea confused with this idea. It's sort of similar in a sense. So, in this case, if we had like 3x, and we had an exponent out here to the 7th power, we could then write this as 3 to the 7th power times x to the 7th power. And that's what this property is illustrating. Now, what makes these problems difficult is that sometimes you have combinations. Like you will use 2 or more of these properties in one problem. Let's look at your study guide real quick. And if you look at your study guide number 1, you have 2 squared times 5, and then you have cubed. Why don't you see if you could simplify this yourself? I'll give you about 30 seconds. And you'll be using one of these 3 properties right now. Or you might use more than one. Okay, see if you can simplify that. It says evaluate the expression. What they ultimately mean and evaluate is they want a final answer, like without exponents. So like sometimes you might use a calculator. I'll let you do that real quick while I pass out some calculators. Okay, so now let me caution you a little bit here. Some of you guys maybe just put this in your calculator and all in one step. And although you can do that, I recommend that you practice using the properties of exponents, because sometimes they won't always be numbers in there. Sometimes you'll have x's instead. And you're going to say, well, I can't do the x's in my calculator. That's right. You can't do the variables in your calculator. So the point is, what I would recommend is that you get used to using the properties instead. So let's see if we can simplify this. Okay, so, and as you might imagine, there's sometimes more than one way to simplify things. Using this property right here and this property together, I could write this as, I can multiply the exponents here. And by the way, when a number is written by itself with no exponent, you can always put one in. You can put a 1 in. Okay, so now if I multiply the exponents, I get 2 to the 6 times 5 cubed. Now, 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2, right? And then this here is 5 times 5 times 5. I would almost recommend that you do that in your calculator, right? Might be easier. The other thing you could have done is this. You could have worked inside the parentheses. Now, some of you guys might have taken this approach. You could say, wait a second, I know 2 squared is 4. And I know 5, and so I get 3. Like that. And so this is another approach you could have taken. And then you could have written this as 20 cubed. And then you could have written this as 20 times 20 times 20, which is equal to 8,000. Now, if we did it this way, we should get the same answer, right? I mean, that's what's nice about algebra and properties. You got to be able to get the same answer, otherwise the properties don't work. So if we did this, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So we would have had 64, and 5 times 5 times 5 is 125. And if you would have multiplied that in our calculator, we would have gotten 8,000 also. So either way you do this, you could have gotten 8,000. Any questions so far? Now, the next problem on our study guide is number 2, and it says 7 cubed times 7 to the minus 1. Well, can you use this property right here to get the answer? Okay, I'll give you 10 seconds. Okay, 10 seconds. Let's see if you get it. 9, 8, 7, 6, 5, 4, 3, 2, 1. Everyone have it yet? You're supposed to. According to this property right here, it says, okay, this is equal to 7, 3 plus a negative 1. But of course, 3 plus a negative 1 is actually 7 squared, which of course is equal to 49. I hope you went in that. Only bozos? Get what?
Stop at 7 squared.
Oh, yeah, right. We were asked to evaluate, so they want the final answer. Now, you might try this in your calculator, and hopefully your calculator gives you the same exact answer. But you may have to use that caret key. We have a caret key on your keypad. Okay, so now you're up to number 3 on your study, right? And we have 8 to the 0 times 6 to the minus 2. And we have this is raised to the minus 1. Okay. We haven't talked about exponents to the 0 power yet. So I'm going to go back to my PowerPoint, and hopefully we'll be able to answer this here in just a few moments. So, you guys ready? We're going to go back to the PowerPoint, because I don't think I've talked about this property yet. Next property. We have a negative exponent. Now, I have to admit, this is the one where people, well, let's just say people screw up a lot on this property right here. Now, I'm going to give you a secret. You guys ready for the secret? Okay, Brenda, I need you to pay attention instead of talking to Emmanuel. Okay, it'd be better if you turned your chair completely around and you're facing the front. Okay, this is, I want you guys all to pass. This is easy stuff if you're doing it. Okay, so let's take a look. I call this the elevator trick. Okay, I'm going to show you several examples of how this works. Here's an example I'm going to show you. What if we have 3 to the minus 5 power? Well, the point is, if you write this, you can move this down to the denominator and the exponent changes to positive. So this becomes 1 over 3 to the 5th power. Now I call it the elevator trick because it works both ways. You can take the elevator going up or you can take the elevator going down. So my point is, if you have 1 over 3 to the negative 5th here, you can move it up and the exponent changes again. So anytime you move it up or down, you change the sign on the exponent. So now in this case this would become 3 to the 5th. Now there's going to be some problems where you can move more than one thing at the same time. So this is a very interesting rule, and what makes it complicated is that we often use these other properties along with it in the same problem. Well, let me just show you a few more examples, okay? So let me get my eraser out here and erase this. What if we have okay, this looks a little bit more complicated. So I'm going to show you step by step how we could use these properties right here, properties 1 through 4, and simplify this mess. Now, often what happens when you're simplifying, it's going to be understood that you should write the answer with no negative exponents. So you got to simplify this until there's no negative exponents. Well, because of this negative right here, I can move this one down to the denominator. And when I do, that exponent is going to change to a positive. So down here I'd have 3 to the 4th. But at the same time, I could move this guy to the top. And when I move this one up to the top, that exponent is going to change also. And so now I'm going to have 3 to the 5th power up there. You see, I've moved them both. Now, this one, well, it doesn't have a negative exponent, so I don't need to move it. So I can think of this as 4 times 4, right? And this one down here I can think of as 4 times 4 times 4 because it's 4 cubed, right? And now I can do some canceling. I can cancel out this 4 or this 4 and this 4 and this 4. Now, by the way, some of you guys can figure out how to simplify this without knowing what the next property of exponents is. I haven't shared it with you yet. But if you expand this 3 times 3 times 3 times 3 times 3, and then we have these 4 sitting here that were canceled already. Okay, I still have these 4 sitting here. And I wrote it out that these 2 canceled out with these 2 already. Down here in the denominator we'd have 4 more 3's, right? And if we wanted to, we can cancel those now. This one would cancel off with this one would cancel off with this one would cancel off with this one, and this one would cancel off this one. There's 1 3 left. And there's 1 4 left down here. So this whole thing would simplify to 3/4. Okay, so I've shown you some examples with these negative exponents and how they work. Okay, we still don't know what number 3, you're working on number 3, right? You have, well, let me write it up here. You have 8 to the to the 0 power, right? Times 6 to the negative 2, and then you have this to the negative 1. We still don't know what this is yet. So we better look at the next property. Maybe we have some more. Oh, there it is. The zero exponent. Anything to the 0 power is equal to 1. Now, you're probably wondering, what the hey? How do you write, how does something multiply by itself 0 times? Think about this for a second. Look, 3 cubed is equal to 3 times 3 times 3. The exponent tells you how many times it's multiplied by itself. So what does 3 to the 0 mean? You don't even have a 3 here, do you? Because it's... So how do you write this? And so I can see why you're confused. To understand how this works, we're going to look at a pattern. Okay? You want to see the pattern? Sure, why not? Mr. Russell, show us the pattern. Well, of course. I'll show you the pattern. What's 3 squared? No, it is 9, but we write it like that, right? In other words, one of these 3's disappeared, right? What's 3 to the 1? 3. And so, what's 3 to the 0 then? Well, each time, it almost looks like a 3 is disappearing, right? So, you say, well, we'd get rid of that one, right? And then we get rid of this one. Well, if we get rid of that one, then why not say it's equal to 0? Our property is saying it's equal to 1. Crazy, right? Looks like it should be 0. Well, so then, by the way, what would 3 to the minus 1 then? How could you even have this scenario? Well, watch out. Let me show you what's really happening here. You don't get 0, you should get 1. Okay, so here's how this really works. You ready? You guys paying attention? If you get this idea, this will be great. Here's what's really happening. When you reduce the power by 1 from here to here, it's as if you're dividing by 3. And so one of these 3's cancels off. Does that make sense? And that's why you have 3 squared now. You see? 3 squared. And now, if you go from here to here, it's as if you're dividing by 3 again. And so one of these cancels off, and so you have 3 to the 1. Okay? Now, so to go here, if we continue with that pattern, what would we do? We'd divide by 3. And what is 3 divided by 3? 1. And that's how this works. And that's why anything to the 0 power is 1.
Wait, so for 3, how do they have 3 to the 0 power times 6?
Yep.
Do we multiply the negative 1 first, or do we just make
Okay, so let's look at this one because we're going to get to it here in just a second. We have 8 to the 0 power times 6 to the negative 2. And then we have this all raised to the negative 1, right? Well, according to what this property is saying, it says anything to the 0 power is 1. Let me just make sure you understand that clearly before we move on. What is negative 2.3 to the 0 power equal to? 1. What is pi to the 0 power? 1. What is who cares to the 0 power?
6?
No, it's equal to 1. Okay? It doesn't even matter what number it is. To the 0 power, it's equal to 1. Okay, so now I think we can answer our question on number 8. Okay? Let's write it out again. I'll give you guys about 30 seconds. And what did we have? We had 8 to the 0 power times 6 to the negative 2. And then we have this to the negative 1. Alright, now you may be using some of these other properties up here to simplify this one. Okay? So I'll give you about 30 seconds, see if you can come up with your answer. Done yet? Okay. There might be multiple ways to go here. That's what's kind of tricky too. I'm going to show you a couple ways that we could go. How many of us want to work inside the parentheses first? You could do that. Or you could use this property right here. You could use that property first. That's what's kind of nice about math, is that you can sometimes do things more than one way. But if we're using the properties correctly, we should get the same answer either way. Okay, I need you guys to pay attention now, so can you stop the conversations on the side? Okay, well, it looks like what I could do is multiply those exponents. That's using this property right here. And it's kind of using this one in the same step also. So this would be 8. What's 0 times negative 1? Oh, use a different color. Oh, my bad, I'm sorry. I will use white.
Marcella said 2.
What's 0 times negative 1?
0.
Now who said 1? 0, well, 0 times a negative 1. You guys, if you don't know this is 0, put it in your calculator. We're not saying 0 plus negative 1. 0 times anything is 0. So this is still to the 0 power. What do we have here? Shh. Come on, we're wasting time. 6 to the negative 2 times negative 1. That's 6 squared, right? 6. Now, according to this property right here, this property tells me that is 1. And 6 squared, 36. Any questions? What if we worked inside the parentheses first? Well, I'll show you another option we could have done. And we should get 36, right? If we multiplied the parentheses here, well, we'd have squared here, negative 2, and then times negative 1. We could have written this as 1 to the negative 1 times 6 squared. And then we could have written this. Now, by the way, can't we use the elevator trick? What happens if I move this down to the bottom? It becomes 6 squared over 1 to the 1. And what's 1 to the 1? Which gives us 36 also. Bam. So the same answer. Okay, so let's continue. Now we get up to the quotient rule. How many do we have here? 1, 2, 3, 4, 5, 6. We have 6 of them so far. This one is very similar. Shh. Similar to this rule. In this case, when you're multiplying, you add the exponents. In this case, you subtract the exponents. So let me do an example. If we have 7 squared over 7 to the 15th, we could say that's equal to 7 to the 2 minus 15. And then that's equal to 7 to the negative 13, which is equal to 1 over 7 to the 13th. You see how we're starting to use multiple properties of exponents? I use that one. I have to be quite honest. To be quite honest, I wouldn't have done this sequence in real life. I don't think I would have done this sequence. You want to know how I would have done it? I would have just done the dumb thing in my head. I would have said, hey, come on, you know what? That's 7 times 7, right? And I would have said, well, that's going to cancel off a couple of them down here, right? Which is just going to change that to a 13. Does that make sense? I mean, let me do an easier one. If you had 7 squared over 7 to the 4th power, can't you think of this in your head? That's 7 times 7, right? And this is 7 times 7 times 7 times 7. And I'm just thinking to myself, okay, I would have canceled off 2 of them, which would have left me with 2 left down here. I mean, that's what I would have done in my head. So I would have just said, oh, well, that's just 1 over 13. Yeah, I just subtract. Yeah, it's the same idea. Here's one more property. We're almost done here. This rule is the same as this one, but it's with quotients instead. These two are very similar. Or should I say, not that one. It's similar to this one. If you have a product inside the parentheses, then they both get the exponent. Well, the same is true if you have a quotient in here, they both get the exponent. So this is pretty easy, right? If you have 2 divided by 3, and this is to the 5th power, then you can write this as 2 to the 5th over 3 to the 5th. Pretty easy rule. Okay, so all right. Take somewhere on your study guide, if you don't mind, can you simplify these two? And what I want you to do on your study guide, I want you to do 1 through, I want you to be able to do the study guide. There's one last topic I need to talk about, and that's scientific notation. I'll spend about 5 minutes tomorrow talking about scientific notation, and then tomorrow we'll work on the book assignment. Yeah? You need a study guide. Okay, so like I said, I will do a 5-minute lesson on scientific notation tomorrow, but I think you have enough information to do your study guide. All right, let's just do these two real quick. Can I put an exponent on the 4? Sure. This is equal to -4 then. And remember, if there's an exponent out here, you multiply the exponents. So 1 times 2 gives me a 2 here. And then you have 2. Well, 5 times 2 is 10. Well, this is -4 times -4. And this is actually 2 times 2 times 2, 10 times. And at this point, I'd recommend putting this in your calculator. And you can check your answer with mine and see if we get the same answer. Now, by the way, this 4 times 4 is going to give you 16. A negative times a negative is a positive. So it's going to be 16 times whatever this big 2 thingy is. 2 to the 10th power. And this one I recommend just using your calculator. 16 times 2 caret 10. And please tell me you got the same answer. 16,384. By the way, one of the significant things here on this chapter is whether or not you can put things in your calculator correctly.
Mister, right here,
Yeah.
I put -128 to the power of 2, and it still kept it as a negative.
Because your calculator is doing order of operations. So if you typed in negative what?
-128.
128?
Yes.
What?
To the power of 2.
Okay, what does your calculator do? It says, please excuse my dear Aunt Sally, right?
Yeah.
And so your calculator is saying, oh, you know what? I have to do this part first because there's an exponent. And then it put the negative out in front. Now, if you want to include that number, you have to put it in parentheses. Otherwise, your calculator doesn't square it like that. Okay, so be careful It's real easy to screw things up in your calculator. Please note, while we're on this little note here, try this in your calculator. I would like you to look at two different ones, negative 2 to the fourth and negative 2 to the fourth. Please understand the difference. These are not the same. This is negative 16 and that one's positive 16. Okay? Make sure if you want that negative to be included, you have to include parentheses. Alright, well let's do this last one. According to our rules, we can multiply the exponent. So that gives me 11, well not 11, hold up. 11 to the negative 5 over 11 to the negative 8. But now I could use my elevator rule. I can move this one up, this one down. That gives me 11 to the 8th over 11 to the 5th. Remember, when they move down or move up, the sign changes on the exponent. Now I could use my quotient property, which says 11, 8 minus 5, which equals 11 cubed. And now I can do 11 cubed in my calculator. And I get 1331. Okay, so again, what we're going to do, we're going to try and do all of the study guide tonight. And then tomorrow I'll talk about scientific notation.
For that, we could do the one in the parentheses first, right?
Yeah, you could have done that first. There's often more than one way to do it, but you should get the final answer. Okay, so I'm going to stop